So thank you so much for coming back on. I'm so excited to have you back. I've gotten so many comments from the YouTube piece, but also I like my young onset group that we text message back and forth. Somebody brought it up the other day when somebody else was talking about constipation or whatever, and everybody just raves about it. So, and I'm still on it. I got off for a little bit just because I was lazy and didn't order it, and then I was like, oh. After like 2 months, I'm like, yeah, I can tell a difference. So back on, and I did the reoccurring cycle, so I don't have to remember. It just happens and it ships. So thank you so much. Welcome to The Secret Life of Parkinson's, a podcast created by people living with Parkinson's to help break the stigma of a disease no one likes to talk about. Now, here are your hosts, Jessica Krauser and Brian Baker. But you and I were talking, and you said you had a new topic that you wanted to share. So I know nothing about this new one.
So, well, they're all sort of interconnected to the microbiome. And since you mentioned constipation, I'll kind of double back to that. And so I've been working on with our data and with like very detailed feedback of what's going on with John and how he reacts with different foods or his body temperature. And the scientist that's helping me is a gentleman by the name of Dr. Barry Ninham, who was the founder of the Department of Applied Mathematics at our Australia National University. He's a colloidal chemist, and I got introduced to him. And one of the things I talked to him about was the consistency of the Parkinson stool, which I think maybe we discussed that on the last one. Well, because he's a colloidal chemist, he really started looking at, what's going on in the gut and what might be causing that. And so he worked through a lot of kind of pieces of the puzzle that there are these bad bacteria that produce an enzyme called urease. And that urease is produced when the body temperature goes above 37°C, and that may be going on in the gut when you're digesting food or, really anytime you're raising your body temperature. And so then it's producing these CO2 bubbles that kill the good bacteria. And then the good bacteria spill out potassium and calcium and make this really tight colloidal mass that makes it difficult for us to access nutrients. So that's going to tie to this other paper I'm going to talk to you about in a minute. But so you can't access the nutrients, so you're nutrient deficient, and you've got this very hard constipation with the potassium and calcium.
So real quick, we also did an episode with Dr. Patel, one of the movement disorder neurologists here, a few months ago on SIBO, small intestinal small intestine bowel.
Small intestinal bacterial overgrowth.
So how is that? Is that kind of like connected in all this?
It is connected. Okay. So, and some of the main SIBO bacteria are methane producers and hydrogen sulfide producers. So that's going to also connect to the second piece of what I want to talk to you about.
Okay.
So it's all interconnected in our gut and to our poo. But one of the experiments that John's been doing actually is basically changing his body temperature when he eats. So when he eats, he takes an ice pack and puts it on his stomach. And so that keeps the stomach from going above that 37°C, keeps it cool so that you don't get the urease production that kills the good bacteria. And we have we did an experiment actually first using a hot water bottle and raising the gut temperature, and it made things worse. Made his feet stick more. He had a lot of problems. And then we went to this ice pack and, proved out that that was basically stopping that production. And he was not having all the he was having really wild metabolic swings between like an acidosis and an alkalosis. You know, it's like the body couldn't maintain any sort of consistency in pH.
So when you said when he does it when he's eating, obviously because it's like food going in your gut, but is it like, are you typically warm then, or it's just, you're just cooling down your body from that cooling down
You're
that
just
part of your
cooling
body?
down your body, which is also interesting because there's a lot of in the biohacker space. There's a lot of discussion around ice baths and
Yeah,
cool pools and all of that
yeah,
stuff. And there's research on that raising your dopamine as well. So perhaps part of the cool therapy
yeah.
and the cold shower, or it is also affecting the environment of the bacteria in your body
Okay.
because you have a different body temperature. And, we have different temperatures in different parts of our body,
Yeah.
which is also, I mean, bless John's heart, he calls himself lab rat number one because we do a lot of different
Yeah, I can
experiments.
only imagine.
Scientists I'm talking to. Well, like we've done experiments where we measure, like we take his temperature in 3 spots across his forehead multiple times a day. And his body temperature is typically about 2 degrees below normal in the forehead most of the time, which is kind of, so there's some
Yeah.
crazy stuff about that we don't have to go into today. But
So you guys just put a paper together, or you already have it written?
we're working on a paper right now with this Parkinson's theory that will have the temperature
with
and
the
the
temperature.
ureas. But so one of the more prominent symptoms that John had when this was going on before we started using the ice pack, when he would have these metabolic swings, he would also have a pretty significant drop in blood pressure. And he had several days in a row where his blood pressure was like 60 over 38 or something. I mean, no wonder you can't walk if you have blood pressure like that. So all of that has stabilized.
And did his blood pressure drop just like after he would eat, or just randomly throughout the day?
I can't say I did a well-controlled experiment enough to, it would be low in the morning.
Yeah.
And so, so we started doing that ice pack overnight. And then when he woke up in the morning, it was normal. So
That's interesting. So what does that
very
say then?
And low blood pressure also over time, in Parkinson's is a symptom that develops over time. And a number of the medications for Parkinson's actually lower blood pressure.
Yeah. So what does that say though for like high temperature locations? Does that affect people?
Well, that would be a really interesting question to see if people in high temperature location, if there's a difference in Parkinson's in high temperature locations. I think some of it though ties to maternal ancestry and your mitochondrial haplotype. So John is from his family is from Ireland and northeastern Europe, which is a cooler climate, and people from those latitudes have uncoupled mitochondria, whereas people who are more equatorial have coupled mitochondria. So there are some differences that.
Go ahead. Sorry.
That may be associated with the cold temperatures and the acclimation to cold versus hot.
Yeah, I'd be almost interested in, because to me it would make sense if you see a higher number of people with Parkinson's in some warm climate areas. Yeah, because as they get older, the snowbirds go to Florida or Arizona, so warmer climates to get away from the winters. But to see the advancement of the Parkinson's within those communities, does it advance faster
In one area versus another?
Yeah.
Yeah. Well, there would be some confounding factors because when you move to the warmer climate, you get more sunlight. And there are a lot of factors related to sunlight that also affect the microbiome. They affect your vitamin D, which affects your immune system. And, Parkinson's is neuroinflammation. So I I would think for the most part, being in a sunny area would benefit you, but you would probably still need to do the cooling down. And that also ties a bit to endurance athletics. So one of the things I've been looking at, because John was a marathon runner, and I've talked to a lot of people with Parkinson's who did some kind of endurance athletics. And of course, when you're doing that long distance training, you're overheating your body, you're throwing your electrolytes out of balance. And so you're kind of constant, and you're frequently carb loading. So there's a lot of metabolic swings in the process of being an endurance athlete that may, destabilize the system.
Yeah, because now that I think about it, like even just saying if you go to like warmer climate, just because you're outside in the sun in Florida doesn't mean that your body temperature like should change. So I guess it makes sense that like either you if you use an ice pack, whether it's cold out or hot, your body temperature should always be relatively the same. So how does that then connect with the SIBO thing? So people who have the small intestinal bacteria thing, what can this help?
So some of those bacteria can be the urease producers.
Okay.
But some of the main bacteria that are involved in SIBO are hydrogen sulfide producers and methane producers. And those are pretty well documented in Parkinson's microbiome research, that there's elevated hydrogen sulfide producers and elevated methane producers. So, one of the papers I get a lot of questions about, a group out of Finland, it's probably been about a year, but it was in the headlines off and on for probably 6 months, about a species of bacteria called Desulfovibrio being the cause of Parkinson's. And, what I would say to people is, it's probably a little more complicated than that, but Desulfovibrio is a hydrogen sulfide producer, and hydrogen sulfide is, a toxic gas.
Okay.
And then there's an archaea that's well documented in Parkinson's called Methanobrevibacter, and that's a methane producer. So in both of those, you can actually get, I know you can get the hydrogen sulfide breath test, because I've done it myself at LabCorp or, one of those. And you have to drink this stuff. I think what it does is it feeds the bacteria that produce the hydrogen sulfide. And then you wait 30 minutes and you blow into an airbag, and they collect that and send it off and see if you have produced hydrogen sulfide.
Huh. Interesting. So are you developing any product to help with this increased body temperature thing, or is it just the research behind?
Well, that's the research behind it. But I mean, essentially you want to get rid of those bad bacteria that are producing the urease. But in the interim of, really trying to address the reshaping of the microbiome, that's one potential solution that also reduces the population of them and is fairly simple to do.
Yeah.
But the paper we're working on is a little broader than that, because it's temperature, it's salt concentration. So a lot of the salt that we get in our diet today is just sodium chloride instead of, a sea salt, a mineral salt that has the full complement of minerals. So, sea salts will have somewhere in the range of, I think, 72 to 74 minerals complexed with the salt, and most of the salt in the food supply is just sodium. And so that sodium is affecting a lot of things related to the electrolytes, but also to the lining of the gut and the lining of our cells. And so that's part of the publication that we're working on with this hypothesis of Parkinson's and how it's all interconnected to that. But so disulfovibrio, this hydrogen sulfide producer, it's a sulfate reducing bacteria. And there's also some research. I was just looking it up. There's a paper by someone named Jeffrey Gagnon where they showed that hydrogen sulfide and a sulfate prebiotic could stimulate this GLP-1. And of course, we know there's all this craze about GLP-1. And there's even been, I have seen some people mentioning GLP-1 as a potential therapeutic for Parkinson's. And, there's some interesting things there, but hydrogen sulfide is regulating GLP-1, but it increases insulin secretion. And but the GLP-1 drugs actually reduce the disulfovibrio. So that might actually be the mechanism of action of those GLP-1 drugs.
And by GLP-1 drugs, you're talking about
like Ozempic.
Yeah, Ozempic, and there's a couple of them out there that for those that need to dumb down.
So say that again with using those names. So the what's the word again that you're using? I can't think of it.
Yeah, it's a mouthful. Disulfovibrio. So it's DESULFOVIBRIO.
So that's and that's good or bad?
It's bad.
Okay.
In general, it's also found in wastewater and a lot of the animal feedlot waste and our sewer systems. So very possible that it's not getting fully cleared in the water treatment. And so that may be why it is, more widespread.
So say, because I'm trying to like piece that together, what Brian was saying, just using the GLP, you said GLP-1? Am I saying that right? So say that again, the part for me, because I didn't quite understand.
So what was interesting to me is I found a paper that was talking about hydrogen sulfide and a sulfate prebiotic that would feed the bacteria that produce hydrogen sulfide would then increase GLP-1. Well, I thought, theoretically, that's not a good idea because you're going to feed disulfovibrio.
Okay.
Right? So you probably don't want to take something that's going to increase hydrogen sulfide production. Plus, hydrogen sulfide plus iron is what knocks out the respiratory chain, cytochrome, and that messes with your energy production, which is well known in Parkinson's, elevated iron and the cytochrome not working for proper energy production. So those pieces together to me were like, okay, you don't want to take a hydrogen sulfide bacteria and you don't want to take a sulfate prebiotic if you have Parkinson's, I would say, because that hydrogen sulfide is implicated there. But what was interesting is the GLP-1 drug itself actually lowered the disulfovibrio. So I think that is, the body reacting, going, okay, well, we don't need to make this anymore because it's, we're taking it.
So this is like the new thing that people, I've seen it a bunch of times, like Parkinson's patients might be able to get benefits from a diabetic or diabetes type drug, right? Is that?
Yeah.
That's what.
So that's what that is. I mean, I'm not. I'm not telling people to run out and do that, but it's an interesting connection to that strain of bacteria. And I'd really like to talk to the people in Finland and connect that dot for them and see what they say about it.
You got
it's But, hydrogen sulfide is also a scavenger of something called acrolein. That it is a compound that a researcher friend of mine at Denver University found in the blood samples of people with Parkinson's. And I think he's going to publish something on. So sometimes those things are there because they're trying to fix a problem in the environment.
Okay.
So, you've got a problem in the terrain. And so you have these bugs there trying to solve that problem in a way that's producing something else that's harmful. So
interesting.
But the other, I mean, that one comes at it kind of from a negative perspective because this is the bacteria that's causing your problem. Yeah. And in the last month, there was a publication came out. It's called a meta-analysis. So they took multiple studies from whole genome sequencing of people with Parkinson's around the globe. I think it was 6 different cohorts. One of them was actually the cohort of samples collected in our Parkinson's research, which was kind of funny because people started writing me about the study or about the headline in the news. So I went and pulled the study and I was like, oh, we're in here.
That's awesome. That's great.
That was kind of interesting, but it's talking about people with Parkinson's having significantly reduced production of B2 and B7. So B2 is riboflavin and B7 is biotin. And so the headline reads, people think, okay, I'll run out and take B2 and B7. That's going to solve my problem. Well, all the B vitamins are actually interrelated in the TCA cycle in the gut with bacteria. And so, there are imbalances in the bacteria that produce these B vitamins because the gut's not healthy. So it goes back again to having a healthy gut overall and restoring the balance in your gut and restoring those B vitamin producers.
So is that like, how people have talked about, is it B1 thiamine? Is that right? So I'm supposed to do a segment on that. I haven't had a chance to do it, but there's like a book on it. So what do you know about that? Because I get questioned all the time.
Yeah, that one's really interesting because I've had some Parkinson's people I know who sort of biohacked with B1. And, there are definitely some benefits to B1, but it can also cause problems. So as an example, a friend of ours was following the Italian doctor who started the information around that. And she did a day where she did, I think, 4,000 milligrams. It was a very large amount of B1. And she said it was like I didn't have Parkinson's. It was incredible. And then the next day she had this huge crash. And so, like, when I think, again, I wish I had a diagram to pull up for you, but I have one somewhere that shows where all the B vitamins are made in the TCA cycle and which bacteria are making them. And I think what happened when taking a high dose of that, if the bacteria weren't there to start to convert those metabolites as they came around the metabolic circle, you get a buildup of a lot of intermediates that, have, nowhere to go.
Yeah.
But that kind of sits at the top, if I'm remembering correctly. It sits at the top of that cycle and then feeds down into the other B vitamins, as you go along. And but Lactobacillus plantarum, so that's the single strain of bacteria that is in the, I think it's called Neurali now, the Neurali probiotic.
It's like isn't it every probiotic has that one, Lactobacillus?
Well, so Lactobacillus is a genera of bacteria that are the lactic acid bacteria.
Okay.
So that would be the first part of the name, and then the second part of the name, like plantarum, is the species, and then you have a strain specific, like ours is Lactobacillus plantarum TBC 036. And theirs is P127 or something.
Okay.
So, but Lactobacillus plantarum is a B2 riboflavin producer.
Oh, okay.
That specific strain of or species of bacteria,
Mm-hmm.
in most cases, will have the full pathway for producing vitamin B2.
Okay. Interesting.
Are you getting all this?
I am. I wrote a bunch of stuff down.
So what I have down is take a complex B vitamin, and it'll cure my Parkinson's. No, I'm just joking.
No.
Well, it's interesting. So there's a neurologist named Dr. Gomniak. I have some links to some of her stuff on my Martha's Quest blog, but I think her website is actually called Right Sleep. So she's been focused on sleep and the importance of sleep. But she has some really good YouTube videos where she talks about the B vitamins and neurological problems and needing to take the B vitamins until you can get your gut straightened out to be able to make them. Because ideally, you want to be able to make them in your gut.
Okay.
But, if your gut's not right, and we know the Parkinson's gut isn't totally right until you can get it straightened out, you probably need to take some B vitamins.
But how do we get it right? Like, is it the healthy eating and probiotics, or is it like what?
So, I think it's diet, it's probiotics. Diet is a huge part of it, lifestyle, toxin exposure. And, I think as we start to learn more about those causal factors and be able to peel those away and get rid of them from our food supply, we're gonna be healthier and healthier, and people are gonna do better.
Yeah.
But the lining of the gut, whole gut health, is very important.
Yeah.
There's also there's a woman, Dr. Natasha Campbell McBride, and it's probably 15, I don't know, it might be 20 years old. Her book is called Gut and Psychology Syndrome. But she worked a lot with autistic kids, and there's a lot of overlap between autism and Parkinson's gut microbiome. And her focus is on rebuilding the gut lining with a traditional diet that takes out all the inflammatory foods. So, you're doing a very like bone broth and a more ketogenic diet to rebuild the gut lining. And so it's a phased approach. We have done some of that work in the process of trying to figure this out. And, honestly, I think too, fecal transplant maybe in the next 3 to 5 years will be something that's more widely accepted.
Yeah.
But it's interesting because there were 2 studies in Europe using fecal transplant. One came from the bottom up and one came from the top down. And the bottom up one was not successful, but the top down one was successful. And one of the reasons why I think the top down approach was more successful is because of SIBO, because SIBO is in the small intestine. And if you're doing a fecal transplant from the bottom up, you're only getting into the colon. You're not getting into the small intestine. Whereas if you're coming down from the top, you're getting it into the small intestine, where you really need to. You're not supposed to have colonic bacteria in your small intestine.
Okay.
So it's and that is where you absorb all your nutrients. So if you think about it, if colonic bacteria have made their way up and you do have SIBO, then they are stealing your nutrition. So, and that sort of goes back to that B1, Derek Lonsdale, who wrote the initial book on that. It was called thiamine, or B1 thiamine deficiency, high calorie malnutrition. Which is kind of the Western diet is high calorie malnutrition.
I think we should have Martha on once every 6 months and have
Just
a
to get
Martha's
updates.
Corner gut health education, because I'm like just sitting here. I'm like, I can
know.
ask you
It's
1,000 more questions, but I know it's like we're coming up on time. But you're like, I love hearing the
wealth
stuff
of
that you're doing.
information.
But the takeaway you should take is have an ice pack on your belly when you eat next
Yeah.
time. I'm gonna try that.
I mean, that's a nice, simple trick. I have a couple of people with Parkinson's who are trying it out for me as, kind of a, let's do a little biohacker experiment
Yeah.
and get back to me. Let me know if you notice any changes in your symptoms when you do that. Because, maybe we'll find some simple and free things we can do.
Exactly. Might as well try. Doesn't hurt.
Doesn't hurt.
Not going to hurt you.
Especially-
I don't recommend the hot water bottle, though.
Yeah, that didn't sound like too much fun. Well, thank you so much again for coming on. And like I said, I'd love to have you back on, see what you're up to in another 6 months. But in our last 30 seconds, I will leave you with this. I think we could probably state this multiple times on every single podcast, but none of us are neurologists, medical professionals. So please just take our information as what it is. And oh, there's my pill time. Sorry. But just make sure that you're always talking to your doctor, hopefully your movement disorder specialist, and what's right for you. But definitely work to keep a healthy gut. Don't eat donuts like I was going to. And hopefully you can help alleviate some of your symptoms just by being healthy. Thanks for tuning in, and we'll see you next time.